Hello everyone, this is Akansh Suman here. Now we are going to discuss the topic that is very important from exam point of view, that is interference. What is the meaning of the interference? You can just simplify this. Interference means just interfere. Okay, when you interfere with something, when you interfere in the someone's matter, that is basically the interference. That is the simplest meaning, interference. Okay, it would be easy to understand when you simplify this name. See, we are going to understand the interference using the diagram. Okay, see here, there are circles. The black dotted line shows the pitch circle for the gear and the pinion. Okay, this is gear and this is pinion. And red color line representing the base circle for gear and the pinion, and green color line representing the addendum circle for gear and the pinion. Okay, now what is a law of gearing says? We have studied that the law of gearing is satisfied when the line of action is passing through the pitch point, that is fixed point, and it is tangent to both the circles, both the base circle of the gear and the pinion. Okay, so this is basically the line. This is basically the law of gearing. So law of gearing must be satisfied for the body to be considered as a gear. Are you getting my point? And we are studying the gear of involute profile. Our profile of gear is involute. Okay, so that means there is a involute connection. Okay, involute connection for gear and the pinion. Now this is the path of contact. KL, we all know that KL is considered as the path of contact, in which KP is path of approach and the PL is path of recesses. It doesn't matter said what is the length of KL. See, it is the path of contact. That means there is a start of the engagement from the K and ending the engagement at L. Okay, now what would be the addendum radius? If I draw the addendum radius for the pinion, it can be like that. Yes or no? This would be the addendum radius for pinion. Now if I increase the path of contact, what is the limit for the path of contact is possible? It can go up to this point, because law of gearing always be satisfied. Law of gearing must be satisfied, and we know that our locus of point of contact is along the straight line. That means along the path of along the line of action. So it can be go up to this point M. Okay, and this K go up to the point N. Are we getting my point? This is the maximum limit up to which the addendum circle goes up to that. Yes or no? So I am saying this is the maximum limit. Means if I say this point enter, that means that if addendum circle enter into the base circle, suppose it will close the boundary of the base circle. We all know that we have seen in the diagram of the base in the tooth profile that if this is the pitch circle and there will be the base circle and there will be the addendum circle like that here. Okay, we have seen that this portion of the gear below the base circle, the portion of the gear or pinion is considered as the non-involute portion. Yes or no? This is non-involute portion. Non-involute portion. So if the addendum circle entered into the base circle, that means if the limit of the path of contact, that means the L will enter into the M. Beyond the M, it is go beyond the M, it will close the base circle boundary. That means it is enter into the non-involute portion. Yes or no? That means the involute tip of the pinion will touch the non-involute flank portion of the gear. So I am just writing here that as you cross the boundary of the base circle, that means if RA, first case I am considering, that means the radius of the addendum circle, if it is greater than O to M. Yes or no? If RA is greater than O to M, that means there will be the involute tip of the pinion. I am just writing here involute tip of the pinion. Involute tip of the pinion will touch the non-involute flank portion of the gear. Will touch the non-involute non-involute flank portion of the gear, because this is gear and this is pinion, so involute tip of the pinion will touch the non-involute flank portion of the gear, because the non-involute portion is below the base circle. What will happen? Portion of gear, then what will happen? There will be a involute non-involute connection. There will be a involute non-involute connection. So if there is a involute non-involute connection, that means law of gearing is not satisfied. Yes or no? Involute connection, because we all know for the law of gearing, line of action must pass through the pitch point and it is tangent to both the base circle of gear and the pinion. So there will be a involute non-involute connections and law of gearing is not satisfied. So I am just writing here law of gearing is not satisfied. And what would be the next point? Law of gearing is not satisfied. See, when the involute portion of the pinion will touch the non-involute flank portion of the gear, that means it will remove some portion, it will remove some material from the non-involute portion of the gear. Yes or no? It will remove some material from the non-involute portion of the gear. So here I am going to write that involute tip of the pinion will remove some material. Yes or no? What is this process? Will remove some material from non-involute portion of the gear. What we will call this process? Non-involute portion of gear. So we call this process as undercutting. So this process of cutting, this removal process of material, this removal process of material is known as undercutting. So I hope you are getting my point. What is undercutting? When the involute tip of the pinion will enter into the non-involute portion of the gear, it will remove some material from the non-involute portion of gear. Okay, so this removal process of the material is called undercutting, and similar procedure will be applied when, and similar process, similar conditions and similar result will be there. Similarly will be there when RA, that means the addendum circle radius RA. What is RA? RA I am going to just denoting you. That would be the RA. Okay, this is RA. Okay, so as the radius of addendum circle for gear RA is greater than O1n, because the maximum limit is n. Maximum limit is n. O1n. Then the similar procedure will be there. That means there will be no non-involute connections, and the law of gearing is not satisfied, and the involute portion of the gear will remove some material from the non-involute portion of the pinion. Okay, so that process is undercutting. So similar process will be there. So I can say that M and N, that is on the base circle, M and N will be the critical point. Yes or no? So I can write here, these are the critical points. Okay, or you can say interference point. This is critical points and the interference point, or you can say last safety point. Safety points. Okay, I hope you are able to understand the meaning of interference basically. Okay, now since we have seen that the interference is not good for ear and the pinion, so we just have to remove the interference, or we just have to we just have to minimize the possibility for the interference. So next, in the next topic we will discuss the method of prevent interference. Okay, how can we prevent how can we prevent from interference? There will be a number of the number of methods, so we will discuss each and every method to remove or to reduce the interference process. Okay, so I hope you are going to understand.